Okay, so watch one more time. So our goal is to define variables, parameters, constants related to this this problem, and then form some relationships. So the first thing it says define constants. What kind of quantities in this situation are constant? So I'll do constants up here. Fortunately, all right, that's the best we're going to do. Okay, so I want to do that. Okay, so I'm going to got the problem up there and got some room to write. Okay, so some constants. Constant quantities in the situation. So here's a constant. They gave you a number. They said the ripples expand to a radius of 2 meters before dissipating. So kind of like the final radius is a constant. So let's write that down. Final radius, 2 meters. Okay, what about the radius of a ripple? Constant or changing? Changing, so we want a variable for that, so we'll do variables down here. So we can call r the radius of the ripple, and we want to specify units, meters. Because they said that the largest radius was 2, and so that gives us our domain for that variable. What's the domain for that variable then? 0 to 2, including 0 and 2. Okay, so what else is, so we got the final radius is constant, but just the radius as this thing is as the ripple is moving is changing. Okay, and then what else, what's another constant in this situation?
Number of water droplets.
Okay, number of water droplets. Okay, that's true. Volume of what?
Water.
Volume of the water in the bowl.
The frequency of the ripples.
Volume of water in the bowl. Okay? So there's going to be another important constant for the future questions here, talking about relating the area within a ripple to time elapsed. So it's going to be another important constant. Yeah? What's that? Sure, pi is a constant. But there's going to be another important, yeah. Yeah, so the speed of the ripple, okay? And so looking at that animation, it looks like it's constant. So do we know what that rate is, that speed?
No.
Okay? But if it's constant, then what do we use? Parameter. So I'll call it S for speed of the ripple, or speed of radius expanding in meters per second. Okay, so here's some constants. The final radius, the number of droplets, the volume of water in the bowl, pi, and then S, the speed of the radius expanding. So now variables. What is changing in this situation? Okay, the area inside the ripple. And what's the domain for that variable? So that's in meters squared. What's the domain for that variable? 0 to pi, and we know it. So what pi what? Not pi r squared. R is changing. We want this. We want the domain. We want to know the greatest, the least, and the greatest value of a. So r is changing. So pi times, yeah, pi times 2 squared, or 4 pi. So from 0 to 4 pi is our domain for a. Why? Because that's the area when that radius is at its max of 2 meters. Okay? Other changing quantity here. There's one more changing quantity that will be important. Yep, but the days of t equals time are over. Okay? When you define a changing quantity, you want to be overly specific. Okay? So exactly what time are we talking about? Time elapsed since the drop hit. So d equals distance is, you'll never do that in this class, or if you do, it won't be right, because it's not specific. In a given situation, you can name a dozen distance quantities. In a given situation, you can name a dozen time quantities. Like in this one, we could say time since the first ripple reached its maximum size. That'd be a different time quantity than this. Okay? So time elapsed since the drop hit the water, and that in seconds. Okay, so we got several constants, and then we got 3 variables. And that was A and B. Express the relationship between the outermost ripple's radius and the enclosed area. So we did that in terms of we defined outermost ripple's radius and enclosed area. So they want a relationship between those two, which is pi r squared equals a, right? That's a relationship, a mathematical relationship between those two changing quantities. As r changes, a will always be pi, whatever pi r squared is. Okay? Now express the relationship between the outermost ripple's enclosed area and the number of seconds since the droplet hit the water symbolically. Is there a question?
The previous question, if the book says like express it symbolically, you just write the equation that stands the answer to the question.
Yeah, these are symbols. A equals pi r and squared. Those are symbols. So symbolically means a equation, expression, something like that. Yep. Using symbols. That's what that means. Okay. So express any other questions right now? So this last one, express the relationship between the outermost ripple's enclosed area and the number of seconds since the droplet hit the water symbolically. Again, what are the constants and variables are in this relationship? So we have what? We have A related to R, and this one they're asking for what? A related to T. So we want A equals something with T's in it. Something with T's in it. Now, just because it's going to be something with T's in it doesn't change the fact that it's area. So it's still going to have this structure. It's still going to be pi times radius squared, except we don't want r anymore. We want it in terms of t. So what's the middleman here? So what do we need to get a in terms of t if a is pi r squared? Well, we need radius, but no longer just r, but in terms of t. So yeah, so we need r in terms of t. So we need a middleman first, r in terms of t. So how can we write the radius, which is a distance, in terms of the time elapsed since the drop hit the water? So distance equals, distance is rate times time, right? Rate times time. And what is our rate of our radius? S. And what is our time since it's started? T. So what you needed, what they didn't ask for, was radius related to time. That was the middleman that you had to come up with, but they didn't. You had to come up with that yourself. That wasn't an intermediate question. So you need the radius in terms of t. And now that we have radius in terms of t, we're going to follow the structure of our area equation to get it in terms of t. So what would it be? It'd be pi times, what is r? R is st. Because distance equals rate times time. Okay? And then, but that's squared. So we got how many things there? 4 symbols. Talk to the person next to you. Which of those 4 are variables and which are constants? Take 30 seconds. Go. Okay, so it's simply a matter of going to each symbol and saying, does that represent a quantity that will change, will take on many values, or will that, in our given situation, will that quantity keep the same value? So A. Variable changes, right? As time goes by, the area gets larger. Okay? Pi. Yes. Better stay constant all semester. Okay? All right? And then what about S? It's a constant, right? That's kind of what we assumed, that the area was expanding at a constant rate. Or, I'm sorry, the radius was expanding at a constant rate, and then time. Variable, right? Time is 0, then it's 1, then it's 2, then it's 2.5, then it's 3 seconds. Questions? Follow-up questions on number 2? Okay, let's do top hat on the reading. Find the file. Are you able to open it? Okay, does it look like this? Okay, I'll give everybody else a moment. Make sure everyone's getting there. Anybody not there yet? Anybody not there yet? Oh, everyone's got it. Awesome. Okay, so if you go ahead, so I've set up this activity for us here, and this is the file. If you go up here to graph, the graph menu, and you come down to draw axes, I currently had the axes off, so turn draw axes, turn the axes back on. So this is our Cartesian plane. Those are the axes. But for this particular activity, we want those off. So this is the axes themselves, the x and y axes. You're just going to have, imagine them in your mind's eye, okay? Because we want those off for this activity. So we'll just burn them into your eyeballs, but then we'll turn it back off again, okay? So now we're going to click on draw axes again, turn it back off. Okay, so what I want you to do is, before we get to the graphing part, I want to explain to you how in graphing calculator, lowercase n is reserved for a variable for which you get what's called a slider. So just everyone hit in this first command line, just type n. And when you do that, it'll say equals some number, and then you'll come down here and you'll see this little thing appears. Okay, this is called a slider. And so it's very much like an independent variable in that the slider allows us, the user, to change its value. Okay? So I can come down here, I can either hit play and just let it play, or you can click, get on, drag on, hold the slider. What's the word I'm looking for? Grab. You can grab the slider and slide it manually. So this should feel like the idea of an independent variable. Okay? We have control over it. We have control over its current value. And then if anytime n is in a command line, then it's going to assume the current value of n, whatever it is in the slider. So right now, n equals 2.7. So we can make an expression out of that. 2n minus 3. So my current value of n is 2.7, and the current value of the expression 2n minus 3 then is 2.4. And as I change n, it will tell me what the current value of the expression 2n minus 3 is. So when n is 7.8, 2n minus 3 is 12.6. Okay, so this lowercase n is a built-in slider or independent variable in graphing calculator. So here's what our goal is, your goal. So here's the same thing. So what we want is these two command lines. We're going to set up these two command lines so that when you move the slider, look what happens. I'll just play it. So there's a command line for this blue bar representing what? The current value of x. And then the corresponding current value of y is shown by the red bar. And so one command line for each. So let's review. How does graphing calculator display a graph? How does graphing calculator display a graph? So let's talk about this blue line right here. How is it displaying that graph? Or how does it plot that graph? Do you remember what we talked about? Yeah.
Yeah, just put the.
I'm not asking you what to write up there. I'm asking you, how does it display this graph? Yes, sir.
It solves the equations for ordered pairs and then shows that pixel.
Okay, right. It has to do with plotting every point, pixel by pixel, right? So we want a command line that represents all ordered pairs from here to here. And what value is this right here? What value is this? That's 5.35. And if I change n? Maybe, if I can. Now it's 2.6, and what happened? Right, now it's showing 2.6. So we want a command line that creates every ordered pair on that blue line. So graphing calculator reads our mathematical statement and says, oh, I know what ordered pairs you want. You want all the ordered pairs starting from 0, 0 to 2.60. Okay? Now, in order to do that, we're gonna do the x and the y separately. Okay? So you have to specify all the possible x values and all the possible y values, and you want to do that with a comma in between. Okay? So see if you can do it. So you're going to specify all possible x values and all possible y values, and just put a comma between those two statements so that that one statement is representing all the ordered pairs, all the points that that blue line is showing. All right, see if you can do it. And we'll walk around and help. You can work together. All right, so let's talk about y-coordinate first. What about these points? All these points. What can we say about what's the domain of the y-coordinate points? What's true about those points in terms of the y-coordinate? They're all 0. So in terms of y, if we want to graph this blue line, how are we going to specify what y is? Y equals 0. Y has to be 0. All those points have a y-coordinate of 0. Comma. What about the x-coordinates of those points? Let me turn it back on again. Got it. Okay, so what about the x-coordinates of these points? Are they all the same? No. It's many x values. Okay? So we want to graph all the x values here between what and what? 0 and. So we want to use less than or equal to create a range of values for x. Every x value of every one of those points on there. So we're going to use less than or equal to. What will it be? 0, less than, n. See if it works. How does graphing calculator make a graph? It plots all the points that you tell it mathematically. We told it mathematically we want all the points such that y is 0 and that x is every value between 0 and n. And so then what happens when we change n? If I change n, make it 4.95, my blue line changes. Okay, so now, any questions about the horizontal bar showing the x-coordinate? Any questions about that? All right, now watch. Now it's up to you to do the red bar. Make it look just like mine, okay? So see if you can, the second command line now will be for the red vertical bar showing the value of the y coordinate. Okay, who needs help? No, we don't want to do that. No, if you do that, then you won't get the right blue line. You want those to match, they won't match them. It'll look the same, no, but this won't be the same as that. No, but you said you wanted to do 0 less than x less than 2n. Okay, but if n were 2, then you're graphing x from 0 to 4. So you're not going to have the right blue line if you do it that way. So it's not, there's not, you can't do it those ways. We want that to show n. We want that to show n. If you do the 2 up to n, you're not going to show n, you're going to show twice as long. Keep going. Any questions over here? Yes. Blue line is n. Third value is n. So it's not the blues. You don't want to take blues in this extra value. Red is not blue. Blue is n. So okay, how many people got it? The red. Good. Okay, so what's true about every point on the red line? What's true about every point on the red line? X is equal to 0. And now we want to show all y values. We want all the points with y values from what to what? 0. Less than all the y's between 0 and half of n. And it should work. Okay, so now I'm going to show you something about the slider. If you click on the n, questions about that? Questions about... And again, we're not programming. This isn't a language. This isn't a programming language. It's just purely the math. So that first statement is specifying all the ordered pairs that make up that blue line segment. And then the second line is all the ordered pairs, x equals 0, and everything from y equals 0 to n over 2. You get all those ordered pairs, and so graphing calculator is just graphing all the points that we're telling it to graph. Question? Okay, because look at the relationship between the length of the blue bar and the red bar. So when the blue bar is 1, what's the red bar? Do you see? And when the blue bar is 4, what's the red bar? Do you see it now? Yeah. So the red, yes, always half of what n is. Okay, now if you go to n, click on n, and you get some control over the slider, okay? Lowest value, highest value, and number of steps. So number of steps is like how many increments. So go ahead and put yours lowest value at -6, highest value is 6, and number of steps, 200 is fine, okay? Or something like that. So now, what am I doing by doing that? By letting n, its lowest value, be -6, what am I allowing for now? In our graph. What negative? What are we using n for? What are we using n for? What variable? In x, independent. So if now I'm saying n can start at -6. Right. So now, check it out. And set your n to negative. And so now I'm showing a negative value of n extending to the left and coming down, right? You see it? No, you don't see it. Okay, so figure out y and add 2 more command lines that will do this. So figure out why these command lines are not doing that for you, and append your file to make this work. What's that? You're gonna, the level we're at here, you're gonna have to do new command lines. Leave the ones you've got. Oh, it's time to go. So, why didn't yours show up before? So why don't they show up? So here we got this y equals 0, x greater than 0 and less than n. So now n is negative. Why didn't it show up for you? What is that saying? That's saying graph all points, all x values, points with x values greater than 0 and less than n. So if n is negative 4.62, what are all x values greater than 0 and less than n? If n is negative 4.62, what are all values greater than 0 and less than n? There aren't any, right? Because that's saying x has to be greater than 0. So, what do we need? We still want y to be 0. Okay, we still want y to be 0. Everyone know how to do a new command line, right? Mac, it's command return, PC, control return. Okay, we still want y to be 0, but we want all points, what? What's the least most x value now? N. And then the greatest x value for when we have negative n values? 0. When n is negative, that first line gives you nothing, because there are no values greater than x greater than 0 less than n, because n is negative. So we need to recreate this bar, all x's from n, which is negative, up until 0. So you need if you do a new command line that's got n less than x less than 0, whenever n is negative, that one will show up. And whenever n is greater than 0, your original one will show up. Okay, have a great weekend.